Hello year 9s, welcome back to Mr. Chan's videos. How are you guys? So today in statistics we will be looking at comparing between two different numerical data sets. So what we're trying to do here is, because we have learned how to find a mean, median, mode in the quartile range, and also the the distribution of data, whether it's positively skewed, negatively skewed, or symmetrical, or bimodal. We actually now almost at the final stage of year 9 statistics. So the learning objective will be students are able to compare and analyze the statistics of two data sets. What that means is, once you do a survey, right, you want to actually know what it means, but sometimes it's very hard to know what a data set means unless you put it to another set of data to compare. So for example, the best one would be like when you do exercise, okay, you want to compare whether exercise affect heartbeats or heart rates. So what you have to do is you need to do a do a survey on a group of people before the exercise and also after the exercise. From there, you can kind of tell whether their heartbeats actually change significantly, and from there, by calculating the mean, median, and also the range, etc., you will be able to tell whether the data before and after actually make a difference. Okay, so here there are two ways we actually compare data. The first one is we compare the measure, okay, the central and spread, which I talked about before, which is your mean, median, and a range and interquartile range of each set of them. So you count, so you do a before and after exercise, and you calculate mean, median, range, and interquartile range. From there, you can see if there's any difference. You can actually do this by using side-by-side column graph. Okay, you actually plot them side by side, and from there you can kind of do a comparison. As you can see, like on this column graph, there are actually a few differences. Same as if you do it back to back, a bar chart, and also lastly back-to-back stem plot, which is a very important one. Okay, you will be doing one of these for your assignment, and remember to read your stem plot 12 and then 6. What that actually means is 12.6. In this case, you actually need to look at the scale. The scale there, 6 and then a line followed by 1 means 6.1. Sometimes it can mean 61. It just depends on the scale. So you need to read the scale first before you read the data itself. Okay. So by plotting this out, it actually also allows you to view the distribution of each data set. So from here, we can kind of tell this is a symmetrical data set. Distribution. Symmetrical distribution. So this is kind of symmetrical. Okay, same as this, but this one you actually have symmetrical, and this one is kind of positively skewed because the right hand side is kind of stretched out a bit. So that's what it means. So let's look at a few examples. For this question, we have Sam and Kate are each given a weekly spelling test out of 20 marks. The result over 35 weeks are displayed in a side-by-side column graph. So if you look at here, Sam's and Kate, Sam is the blue color, Kate is the orange color. So they took a test over 35 weeks. And after that, the graph is plotted. So the score is out of 20. Alright, next point. So the question is asking is, A, how many times did each student actually score full marks? So full marks is out of 20. So if you look at this, Sam actually scored 2 times and Kate actually scored 4 times. Okay, there you go. Sam scored 2 times, Kate scored 4 times. Describe the distribution of each data set. So let's look at Sam. Sam, if you draw his data, is actually what happened is the right hand side is actually a little bit is quite stretched out. What that means it is a positively skewed. Okay, Sam, and while Kate data, this is Kate data, right? Kate data actually are quite symmetrical. Okay, so you can actually say they kind of have very different result, if you're going to say, and that's why we plot them side by side. Or else if you plot them individually, you kind of not be able to see this, to make this comparison. But next one is find the range of mark for each student. So range is the highest minus the lowest. Okay, so the highest here is 20 for Sam. The lowest for Sam is actually 12. So what happened is the range for Sam is 8 marks. Remember, range is different from interquartile range, okay? Interquartile range, look at Q3 minus Q1, but for range is literally just maximum minus minimum number. And for Kate marks, you have Kate's highest score is 15 and lowest score Kate, she got 15, which is the lowest. Her highest is 20. So 20 minus 15 is 5 marks. So what that means is who generally has a higher mark? As you can see from the column, Kate actually has more score on the higher end than Sam. So Kate score higher. Who has a greater spread? Spread means who spread or have a bigger spread of data. To know that, you actually need to calculate the range, which has been calculated in C. Sam has 8 and Kate has 5 marks range. So what that means is Sam actually has a bigger spread, alright, because his data is more stretched out, because it's 8 marks different between the lowest and the highest, while Kate is only 5 marks. Okay, so that's what we do when we compare two different data sets. Alright, they have to be kind of similar thing you're investigating. Okay, in this case we are investigating spelling test marks between Sam and Kate. Next slide, I'm actually going to show you example on how to do it if you see one of these, and especially teaching you how to plot back-to-back stem plot. So let's begin. To determine if a weight loss program is effective, a group of 25 men trialed the program for 3 months. Okay, so their weight in kilograms before starting the program were, and you have a bunch of data there, that's before. Okay, that's before starting the program, and after completing the program, those are the data sets. So A, construct a back-to-back stem and leaf plot for the data. So before you do that, you actually need to reorder your data set. Okay, that's always the first step. No matter what, you need to reorder them from small to large. Okay, so step one, reorder from small to large. Okay, ascending order. So if I'm gonna rearrange it, it's gonna look like this. Okay, you can actually pause the videos to rearrange it yourself before and after, because it's gonna take a while. So I already actually pre-ordered them before these videos, so I'm gonna just copy them out. So this is before program. So to help you, I reckon to plot a stem and a leaf back to back, you actually need to reorder the number, okay, according to the what's at the front. So 8. So we have only 179 kilos, and after that is all there are 3 in the 80s, and in the 90s we have 5 numbers. Okay, and then in the hundreds we have 4 numbers. And then after that we have in the 110 we have quite a few. Okay, and 120 we have a few as well. Okay, in the 130 we only have 2 numbers, and that's before, and this is after. Okay, after we have in the 60, we actually have a few in the 60. That means it kind of show you that there are already a few people who have lost weight, because before there wasn't any in the 60s. So make sure you rearrange this data like what I do here. Once you do that, it will just make it so easy to read. Okay. And look at this. By the look of it, there's no one actually in the 130 or above zone, so it kind of tells you that maybe this weight loss program actually works. So after that, once you do that, you actually need to look back to back. So normally what we were going to do is we will do one of these. This is your scale. Okay, 6 and then 8 means 68. Okay, so in this case we actually need to have 6 in the 60, 70, sorry, my bad, 8, 9, 100, 110, 120. Sorry, remember you need to keep the last number. Okay, normally for just a regular stem plot, I mean stem and leaf plot, you only have one side. Okay, so if I'm gonna plot this, it will look like this. Alright, because they're 68, 68, and then that is, for your information, this is after. Okay, after program. I'm gonna plot a before in a sec as well. Sorry, so 74, 78, 29, 79, 3, 3, 4. You to plot stand and leave plot, you just need the final number to be separate out. Okay. 6, 9, 9, and then 102, 106, 106, 107, and 10, 113, and then 122, 125. And then to plot back to back, you actually need two lines, okay, in between that main number. Okay, so you just kind of reuse the second part. And for before program, there isn't anyone in the 60, so we're gonna ignore that 60. And then we're gonna pick another color just to give you a fresh look. So it's not in the 60, there is one in 70, which is 79. So make sure you write it like that, but do not confuse it. It's not 97, it is 79. You need to look the number in that in between those two lines first. And then we have 82, and then we have 83, and then 86. After that we have 93, 95. Oh, that's 4, isn't it? 100, yeah. Oh, good, I did not get that wrong. 7, 98, 99. Remember, each of the time you read the individual numbers. So 93, 95, 97, 98, 99, okay? You only pick one number from the end to read. And then 100, 101, 104, and 104. After that it's 111, 111, 114, 117, 119. And then after that 120, 121, 122, 123, 125. After that is 132, 135. Alright, there you go. I've successfully plotted that. So from there, you actually need to count B. B is your mean and median. So mean is basically you add up. So you need to do 2. Okay, for mean. So for mean, you actually need to do. So you need to find mean and then of before and then mean of after. So pretty much you just need to add up, okay, all this number, add them up. Alright, add them up, sum of all numbers for program, and then divided by 25, because there are 25 samples, which is 25 men. Okay, once you do that, you will get the answer. I've already done it here. Okay, it is going to be 107, roughly 7 kilos. Okay, 107 kilos. And for me after is actually again sum of all numbers after program, and you divide it again by 25, because again it's going to be that same 25 people who took the weight loss program. And then what you will get is 93.4. Can you please actually try this out yourself, so that you can check whether you are on the right track or not, and you will know how to do. I just provide answer there for your reference, okay? So after that, you actually need to find median. Okay, median. So I'm gonna spread this into 2 halves. So median, you actually need to Again, there are 25 people, okay, and median is n plus 1 divided by 2, okay. So let's see, median n plus 1 divided by 2, which is 25 plus 1 divided by 2, which is equal to 26 divided by 2, which is 13. So number 13 is your median. Let's count. So you actually need to count before. So start from here, because we'll rearrange it from top to bottom. So you can count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So it's 104. Okay, it's 104 kg. Okay, and you do the same for after. Okay, which is again 25 plus 1 divided by 2, because they are the same people, 25 people. Again, so it will give you 26 divided by 2, which will give you 13 again. So you need to count from that 13. Okay, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 93 kilos. Okay, so that's how you do it. Remember, you can only count the median once you have rearranged the data, alright, ascending order, or else you will get it wrong every single time. So what that means is, let's look at C. Would you say that the weight loss program is effective? Explain your answer. What do you guys think? Okay, what do you guys think? So my answer is yes, it did make a difference, because what happened is we have calculated the mean and median, and for mean of before, okay, the average mean for every single man is 107 kilos, and after the program they dropped to 93.4, which it is quite a big drop. Okay, if you're gonna calculate in percent, what that means is, I've calculated this beforehand. The mean, they actually dropped 12.7% of their weight, which is quite a big drop. And for median, it went for 104 kilos, the middle number, it dropped to 93 kilos. So yeah, again, it is quite big drop, which is 10.6% drop. Okay, so I would say, because it dropped on both mean and median before and after, I would say that the weight loss program is actually effective. There you go. That's why we actually do statistics. Okay, statistics allows you to do a lot of things and actually give you evidence. Okay, imagine if you don't collect data for this kind of things, like you can never convince people why exercise or why eating food or anything like exercise actually raise your heartbeat and stuff. You actually need to have a concrete evidence to show people why it works. This is why we use, most of the time scientists use statistics to convince people. Okay, so that's it for this videos. So hopefully you know how to plot stem back to back, stem and leaf plot, and actually use that to analyze your data. So thank you so much for listening and watching. Can you please make sure you write the notes down and ask me any questions. Peace out. Bye.